Hey, welcome back to Basic Squared. In this video, I'm going to be doing 10 questions from finding the equation of a line using MathSpace. So let's get into the task. So question number 1 says, state the gradient and y-intercept of the equation y is equal to 2x minus 2. So first thing first, we notice that y is equal to 2x minus 2. This is my gradient. This is y is equal to mx plus c, or in some examples, y is equal to mx plus b, okay? So here, my m is the gradient. So I can write here m. This part here is the gradient. And my c is what we call the y-intercept. Okay? So now, as the question says, what's the gradient and what's the y-intercept? So clearly we know that the gradient is 2 and the y-intercept is minus 2. So let's put that into here. Gradient of 2 and the y-intercept of minus 2. Good, excellent, brilliant. That question is done. Let's go on to question 2. Okay, question 2 is lock and loaded. Let's have a look at this. It says, write the equation of a line which has gradient 2/3 and goes through the point 0, minus 3. So remember, y is equal to mx plus, let's just call it b for now, because I know the next question is going to go on to saying y equals mx plus b, so I'm going to stick with that. So we know here, my gradient is 2/3, because they told me that, and it passes through the point 0, minus 3. At the y-intercept, x is always 0. So look at this. We have a coordinate point where we've got x is equal to 0 and y is equal to minus 3. Whenever x is 0, that means we have the y-intercept. So our y-intercept here is minus 3. We have y is equal to 2/3 x minus 3. It says express the equation in gradient-intercept form. This is my gradient, okay, intercept form. This is my gradient-intercept form. So I'm going to write here y is equal to 2/3 x minus 3. So let's put that here. Y is equal to 2/3 x minus 3. And let's just submit that. Perfect, good. So that's question 2 done. Let's get on to question 3. Okay, so question 3 then, it says a line has a gradient of 5 and passes through the point -1, -4. By substituting the equation into y equals mx plus b, find the value of b for this line. So we know that we've got y is equal to mx plus b. We also know that we have the information, the gradient is equal to 5 and it passes through the point -1, -4. We're going to substitute these values. That's my x, that's my y, and that's obviously my m. I'm going to substitute those values into the formula to see what we get. So we get -4 is equal to 5 minus 1 plus b. So we get -5 is equal to -4 plus b. And what we can do here is we can plus 5 on both sides, okay, using inverse operations. And then that's going to give us 1 is equal to b, therefore b is equal to 1. Let's put that into the equation and see what we get. Okay, here we go. So b is equal to 1. It says, hence, write the equation of the line in gradient-intercept form. Now, this is our gradient-intercept form. So we already have y is equal to 5x. Our plus b is going to be the one that we found earlier on. So we're going to write this as y is equal to 5x plus 1. So let's do that now. Y is equal to 5x plus 1. Okay, excellent. Now it says, derive the same equation by substituting into the point gradient formula. Now I'm just going to tell you very quickly what the point gradient formula is, okay? Y minus y1 is equal to m bracket x minus x1. This is the point gradient formula, okay? Now we already have the values of y1. Let me just highlight this. We have the values of y1 and x1. They were given to us in the beginning as -1, -4. Okay, so imagine here we already have our x1 and our y1. So we can substitute those values into this equation. And remember, we also have the value of m, which was given to us as 5, okay? M was equal to 5. So we're going to substitute those values into the point. Let me just write this down. This is the point gradient formula. Okay, point gradient formula. So let's substitute those values in. Remember they said the gradient was 5, so we're going to replace m with 5, and our x and our y, that's our x and y, or x1, y1, we can replace this with minus 4, and this with minus 1. So let's substitute the values in and see what we get from the point gradient formula. So we have y minus negative 4, so 5 bracket x minus negative 1. Okay, so y minus minus 4 is y plus 4, and then 5 bracket x plus 1. Okay, let's see what we get then. Let's expand this out. So that's 5x plus 5 is equal to y plus 4. Maybe minus this 4 here, minus the 4 here. So you get y is equal to 5x plus 1. Okay, so let's put that into this equation here. 5x plus 1. Okay, part D says graph the line. Now we know a couple of things. We have a point of minus 1, minus 4. We can use that point. And we also have the y-intercept. Remember our equation was y equals 5x plus 1. This is our y-intercept, so the point 0, 1. So we're going to use those 2 points, minus 1, minus 4, and then 0, 1 to draw the line in the graph. So let's zoom into this. We've got, point was minus 1, minus 4, minus 1, minus 4. Let's just double check that's correct. Minus 1, minus 4, yes, minus 1, minus 4, and then 0, 1. They're the 2 points that we're going to submit. Oops, minus 0. Let's just zoom into this. 0, 1. Here we go. 0, 1. Submit that. Brilliant. Okay, good. So let's continue to the next question. Question 4. It says a line passes through the point A, which is 2, 7, and has a gradient of 8. It says find the value of the y-intercept for the line denoted by b. Okay, so we have y is equal to mx plus b. We have it passes through the point of a, 2, 7, and the gradient is 8. We want to find out the y-intercept. Okay, so we were trying to find out the value of this b. So this is what we'll do. We'll substitute the values that we do have. We have x and y. Let's put those into the equation. So I've got 7 is equal to 8 times 2 plus b. 8 times 2 is 16. 7 equals 16 plus b. What I can do here now is minus the 16 from both sides. So I get 9 is equal to, minus 9 is equal to b. Okay, so the value of b in this case would be minus 9. So let's put that into the equation here. B is equal to minus 9. And good. Okay, it says hence write the equation in the gradient intercept form. Remember, this is our gradient intercept form, and that would be y is equal to 8x minus 9. Okay, that's the gradient, and that's the intercept, y-intercept. So let's write that down. Y is equal to 8x minus 9. Okay, again, if this is too fast, then just pause until you're comfortable and you understand what's going on here, yeah? Question 5, it says line 1 has the following equation, y equals 3x minus 6. Find the y value of their y-intercept. Now remember, the y-intercept has an x and a y component. We want to find out what the y value is. Okay, so here in the equation anyway, the equation that they've given, y is equal to 3x minus 6. This is our y-intercept. Okay, so we have the coordinate of 0, minus 6. So the y value, the y component here, okay, is just minus 6. So y is equal to minus 6 because they need to give a variable. So we're going to go here and we're going to say y is equal to minus 6. That's the y-intercept, the y value of the y-intercept. Okay, now it says find the x value of the x-intercept of the line. So we want to find out, again, if we've got an x and a y, we want to find out now the x value of the x-intercept. Now, at the x-intercept, okay, at the x-intercept, we know that y is equal to 0. So we're going to substitute the value of 0 into the equation. Y is equal to 3x minus 6. We're going to substitute the value of y is equal to 0. So we're going to say 0 is equal to 3x minus 6. Now we just need to rearrange to find the value of x. So I'm going to plus 6 on both sides. That's going to say 6 is equal to 3x. Now I can just divide by 3, divide by 3. Therefore, x is equal to 2. Now, x is equal to 2 is the x component of the coordinate of the x-intercept. So it's going to be 2, 0. And they want this part as well. Okay? So they want the 2, the value of 2. So x is equal to 2. That's what we're going to put into here. X is equal to 2. Okay, let's just clear this up because it's a bit messy here. Look. Okay. Find the y-coordinate of a point that has the x-coordinate of 4. Find the y-coordinate of a coordinate that has an x-coordinate of 4. Okay, so we've got, like, if you had xy, we already know that the x part is 4. Find the y-coordinate. So our equation is y is equal to 3x minus 6. We just need to find out what the y-coordinate is of a point that has an x-coordinate of 4. So we can substitute the value of 4 into our equation. We can substitute the value of 4 into the equation to see what the y value is. Okay, so y is equal to, we're trying to find out what y is. 3 times 4 minus 6. 3 times 4 is 12. 12 minus 6 should give me the value of y. 12 minus 6 is 6. So the y value, the y-coordinate of this point is equal to 6. Okay, so in 4, 6 should be on this line with equation y is equal to 3x minus 6. So let's put that into the equation y is equal to 6. Put this here. Y is equal to 6. Good. Okay. Now it says plot this on the coordinate plane. Okay, in the Cartesian plane. So we already have one equation. We have one coordinate anyway. The coordinate that we have is 4, 6. We can use this 4, 6. And we also know from the equation, okay, from the equation y is equal to 3x minus 6, we know that minus 6 is the y coordinate. So we can do 0, minus 6. So 4, 6 and then 0, minus 6. So let's just, first and foremost, let's do 4, 6, okay? So 4, 6, that's 4, 6. And the other coordinate was 0, minus 6. So 0, minus 6. Let's just double check. 0, minus 6, yeah, that looks good. And then 4, 6, I'm happy with that. Let's submit. Excellent. Okay, so let's continue to question 6 now. It says a line has the following equation, y is equal to 2/3 x minus 4. Find the y value of the y-intercept of the line. Now, again, very nice, easy question. The y-intercept, y is equal to 2/3 x minus 4. This is my y-intercept, okay? That's the y-intercept. Remember, the y-intercept has two components to its location, which is the x and the y, okay? So if that's my x, that's my y coordinate. Here we're going to write y is equal to minus 4. That's the y component, the y value of the y-intercept. So let's just write this down here, minus 4. Okay, good. And then it says find the x value of the x-intercept of the line. So find the x value of the x-intercept. Now we know, remember, at the x-intercept, y is equal to 0. So we can say 0 is equal to 2/3 x minus 4. We need to find out what this value is. Plus 4 on both sides. I can say 4 is equal to 2/3 of x. And now I just need to find out what x is by isolating the x. So look what we can do here. We can just say times this by 3, times this by 3. We get 12 is equal to 2x. And then divide by 2, divide by 2. X therefore is equal to 6. Okay, so we're going to put the value x is equal to 6. Third question, or part 3, or part C, it says find the y-coordinate of the point that has an x-coordinate of, let's just clear this out so we can see what it says. Find the y-coordinate of the point that has an x-coordinate of 3. So look, our equation y is equal to 2/3 x minus 4. Find the y-coordinate of the point that has an x-coordinate of 3. So we've got an x-coordinate of 3. We don't know what the y is. We're going to substitute this value, okay, of 3 into the equation. So we've got y is equal to 2/3, x is 3 minus 4. Okay, so look at this. 2 times 3 is 6. 6 over 3 minus 4 is equal to y. 6 divided by 3 is 2. 2 minus 4, y is equal to minus 2. Okay, so y is equal to minus 2. So y coordinate is equal to minus 2. And then finally plot the line with the equation y is equal to 2/3 x minus 4. Again, remember we have the y coordinate. We've got 0, minus 4. We've got that. And we've also got, if we go back up, when x is equal to 3, y is equal to minus 2. So we can use that when x equals 3. When x equals 3, y is equal to minus 2. So we can use these 2 points. We can use 0, minus 4. So let's do that first. 0, minus 4. 0, 4. And then 3, minus 2. So 3, minus 2. Here we go. So we're happy with that. We can submit that answer. Excellent. Let's continue on to question 7. Question 7 said, consider the equation with consider the line with the equation y is equal to minus 8 minus 4x over 9. State the gradient of the line. Okay, this isn't in the gradient intercept form. We need to just move around a few things, okay? Okay, so first thing first, we can see that m is with the x, and that's this part here at the end. So we're going to put that in the middle part. So we can say minus 4x over 9 minus 8. Now that seems to be in standard gradient intercept form. So our gradient, we can clearly see, is this part here, or in particular, it's minus 4 over 9. Okay, so my gradient, which is we call m, is minus 4 over 9. So let's put that in here. Let's submit that as our answer. Minus 4 over 9. Good. It says state the value of the y. State the value of the y at the y-intercept. Now again, look at our y-intercept. Our y-intercept is minus 8. Okay, so we need to just put that in here. Just right here, minus 8. Okay, let's continue on to question 8 then. Question 8, determine the equation of line 1, given that the gradient is 8 over 3 and cuts the y-axis at minus 8. Express the equation in gradient intercept form. Excellent. So gradient intercept form, again, is this. That's my gradient intercept form. They've already given us the gradient, which is 8/3 x, and cuts the y-axis at minus 8. So y is equal to 8/3 x minus 8 would be our equation in the gradient intercept form, okay? So let's write this here. Y is equal to 8/3 x minus 8. That should be good. Let's continue on to question 9 then. Question 9 says, a line has a gradient of 5/2 and passes through the point 7, minus 10. By substituting into the equation, y equals mx plus b, find the value of b for this equation. So let's do that then. We've got the gradient is 5/2, and we've got the point 7, minus 10. So all we need to do is just substitute these values of x and y and m into the equation. Remember, we're going to substitute minus 10 over here, and we're going to substitute 7 over here to find out what the y-intercept is, in this case b, okay? So 5 times 7, that's 35 over 2 is equal to minus 10 plus b. Now, what I'm going to do is I'm going to multiply everything by 2. So I'm going to multiply that by 2, that by 2, and that by 2. That eliminates the 2 for the denominator. That gives me minus 20 equals to 35 plus 2b. Okay, now I can simply just minus 35 on both sides. Okay, minus 20 minus 35 gives me minus 55. Let's just write that here. Minus 55 is equal to 2b. And now all I need to do is just divide it by 2, divide by 2. Okay. 55 divided by 2 is 27.5, negative 27.5. So b is equal to minus 27.5. Okay, good. It says write the equation of the line in general form. Now, in order to write this in standard form, the general form of an equation is ax plus by plus c equals 0, where all coefficients are integers and the coefficient of a is positive. So let's start by multiplying everything by 2 then. So if I multiply everything by 2, times by 2, times by 2, times by 2, I would get 2y is equal to 5x minus 55. And then if I minus the 2y from both sides, I would get 5x minus 2y minus 55 is equal to 0. Okay? 5x minus 2y minus 55 equals to 0. Okay, good. That's the standard, what was the question? That was in general form. Okay, now let's move on to the last question then, question 10. And the question reads, find the equation of a line that has the same gradient as y is equal to 2 minus 2x and the same y-intercept as y is equal to minus 2x minus 5. So we need to take the gradient from here and the y-intercept from this point here, okay? So look, my gradient is minus 2, and the y-intercept here is minus 5. Okay, that's my y-intercept. So we're going to have an equation y is equal to minus 2x minus 5. That's the equation that we're going to have. So y is equal to minus 2x minus 5. And that's it. The task is complete. Okay, that was a long video, but I did see that some students were struggling with that task. So I wanted to go over and just answer those questions. I think a lot of it wasn't the conceptual understanding, it was some of the wording. Okay, the point gradient form and the standard form that threw off some students. But go back, have a look at it. And as always, if you've got any questions, put them in the comment section below. And I'll see you in the next one.